Hello guys, welcome to Coder's Paradise, and in this video we are going to discuss about prefix sum. So in this video we will discuss what is prefix sum, how do we calculate a prefix sum of a given array, and we will also solve a problem to see how we implement prefix sum to solve a particular problem and how to optimize that. So without any delay, let's get started. So first of all, I will explain you what is prefix sum and how do we calculate it. So let's take an example of an array. Let's suppose we have an array ARR where we have the elements 1, 2, 3, 4, 5, and 6. And let's just quickly name the indexes as well. 0, 1, 2, 3, 4, 5. Right? These are the indexes. Now, a prefix sum array is an array having the same number of elements as this ARR, or if we are creating a prefix sum for an array, so the new prefix sum array will have the same number of elements as the our original array has. So let's call this as a prefix sum array. Okay. Now, what this array will contain? This array will contain the sum of all the elements which are appearing on the left of a particular index, right? The sum of all the elements that are appearing on the left of a particular index. For example, let's suppose take 1 as this one, the zeroth index or the element 1. So there are no elements on the left of the 1. So the prefix sum for the index 0 will be the element itself, or 1, right? Now, when we move to 2, this index, index 1 or the element 2, so there is only one element on the left of 2, that is 1. So 1 plus 2 is 3. We need to sum all the elements including that particular index and all the elements which are on left of that particular index. And similarly for 3 it will be 6, for 4 it will be 10, for 5 it will be 15, and for 6 it will be 21. One thing also we need to observe here is the next prefix sum is equal to, if you see here, let's take an example here. So this prefix sum is equal to the previous prefix and plus the element at that particular index 2, that is equal to 3. Got it? I will just explain this with a small table so that you can have the better idea. So let's take prefix sum of 0. What it will be? It will be only ARR of 0 because there is no element on the left of the index 0. Now, prefix sum of 1, it will be equal to the prefix sum of 0, the previous prefix sum, plus the current element, the current index element, that is 1. Got it? Again, for 2, it will be prefix sum of 1 plus ARR of the current element. Again, prefix sum of 3 will be equal to prefix sum of 2 plus ARR of 3. So prefix sum of 4 equal to prefix sum of 3 plus ARR of 4. Similarly, prefix sum of 5 is equal to prefix sum of 4 plus ARR of 5. And if we simplify this, so we can say that prefix sum of I equal to prefix sum of I minus 1 plus ARR of I, where I is not equal to, just a minute, I is not equal to 0. Why? Because if we take I equal to 0, then this index will be the negative side, which we don't want. It will be an error. So for the negative, if I equals to 0, then prefix sum of I equal to ARR of I. Got it? So this is the information that we are taking from the prefix sum. Prefix sum is nothing but a cumulative data. For an example, in a cricket match, you see whatever the run is scored in an each over, but the score is cumulative. It sums all the run scored in every over to provide the total score. This is how a prefix sum works. Now, basically the prefix sum is nothing but if you are going to sum up all the elements for a particular index, then we get the prefix sum. Now let's move on to the one question where what we will do, we will solve this question using without using a prefix sum, and then we will try to implement prefix sum in this and see, and then we will see how we are optimizing this problem. Okay, so let's quickly look at the problem. So the question is, given an array of numbers and q queries. It's a 2D array. It's a 2D array. Find the sum of elements of an array based on the queries, right? And how the queries will be. So we will take an example. Let's suppose there is an array. Let's take an array the same 1, 2, 3, 4, 5, 6, and we have the queries. Queries will be a two-dimensional array. I will explain how it will look like. So let's suppose, so all the subarrays inside the queries will be only of length 2. All the subarrays will be of length 2. Okay. Now, the length 2 denotes the first element will denote the starting index of the array, and the ending index of an array will be the last element. For example, if this is a subarray, here let's suppose take 0, 2, 1, 3, 2, 5. Let's take this array. Okay. So this 0 is the starting index and 2 is the ending index, right? Similarly, this all 1, 3, 2, 5 and all. Okay. Now, what we need to do, for each query, we have to find the sum of the elements of the array from, for example, for the first query 0 to 2, so we have to find the sum of all the elements from 0 to 2. For 1 to 3, we have to find the sum of the elements from 1 to 3. Okay. So let's quickly write the code, a pseudo code. So let's take a function first of all. We will take a function. We'll call it a find sum. It will take a start, end, and the array itself. Okay. So now here we will have int sum for int I equals to not 0, for I equals to start, I is smaller than equal to end, and I plus plus. Then sum will be equal to plus equal to ARR of I, and we will return sum, right? Now we have a function that will find the sum based on a start and the end index. Now what we need to do, we need to, for run this function, we have to call this function for each query. Okay, we have this number of queries, so for each query we have to run this. So we will write for int I equals to 0, I is smaller than q dot length, total number of queries, and I plus plus. What we need to do, we need to print, we will just simply print find sum. We will call find sum with, first of all, we will just quickly write the start and the end point because it will be quite long statement. So we will write int start equal to query of I, the first query of I means the first subarray, and then start will be the first element. Okay. End will be equal to query of I 1, right? Now, what we will do, not a for loop, what we will do, we will print call sum, find sum, we will call find sum with start, end, and the our array ARR, right? So this way, what we are doing, we are just iterating through each of the queries, and we are calling the find sum, which will find the sum and return the sum value, and this print function will print its value, right? Now let's try to find the time complexity of this problem. So the time complexity. So we have an array of length n, right? what we are doing, we are iterating through that array and finding the sum. So what we are doing, we are kind of doing n iterations. So we can say we are doing n iterations for finding sum, for finding, for find sum function. And for each query, for each query, we are calling find sum, which is doing in big O of n, because we are kind of doing n iterations. So total time complexity will be equal to big O of q multiplied by n, right? Why? Because we are kind of finding sum for each query, right? Now let's try to optimize this problem to big O of n, and we will see how we are going to use the prefix sum to solve this. So what we need to do here is we need to find the sum of elements, sum of elements of the given array. Can we can we utilize the prefix sum array to find this? Let's quickly see. So our array was 1, 2, 3, 4, 5, 6. Okay. Now let's create the prefix sum array. It will equal to 1, 3, 6, 10, 15, and 20. Now let's suppose there is one query. Okay, there is one query 1 that says find from 0 to 0 to 2. 0 to 2. So let's take an example 0 over here, and 0 is here, and 2. So let's quickly write down the elements as well. 0, 1, 2, 3, 4, 5. So we need to find from 0 to 2 here. So do we know, using prefix sum, do we know directly what is the sum of the elements from 0 to 2? Yes, we know, that is 6. So the answer will be 6, right? Now let's take another query. 6. Now let's take another query that says from 3 to 5, right? Let's take this example. So from 3 to 5, we need to find from 3 to 5 this sum. So here you can, if you see carefully, we have to find the sum from 3 to 5. So for 5, it is 21. And from 3, if we subtract the prefix sum before 3, it means if we subtract the prefix sum at index 2, and from the total sum it is 21, then we can get the prefix sum from 3 to 5. Because what we need to do, we need to eliminate this part. This part we need to eliminate, right? We need to find for this one only. So if we subtract the from the total sum, which is 21, and we subtract all the prefix sum till the second index, then we can get the value from for this one, right? Simple mathematics. So let's quickly see. So the we can say here the prefix sum will be equal to, just a minute, prefix sum of 5 minus prefix sum of 3 minus 1. What is this 3 minus 2 index? So prefix sum of 5 is 21 minus prefix sum of 3 minus 1 is 2. So prefix sum of 2 is 6. That is 15. For it, calculate. Let's try to calculate, find. So 4 plus 5 is 9 and 6, 15. Right? You can see here. 4 plus 5 plus 6 is 15. Right? Now let's generalize this equation. So we can say that prefix sum from I comma j will be equal to prefix sum of j minus prefix sum of I minus 1, right? But there is one thing to note it down. But if I is not equal to 0, because if I is 0, then the prefix sum of I minus 1 will be a negative index. That is not possible. So we can say that if I is equal to 0, then prefix sum of I comma j will be equal to prefix sum of j. Why? Because in the first example here we have discussed here, prefix sum of from 0 to 2 is 6. 6 is the second element, which is prefix sum of 2, right? Let's quickly code it and see the time complexity. So first of all, we have the our array ARR. We need to find the prefix sum. So let's try to find the prefix sum. Find prefix sum. So for int I equal to 0, I is smaller than ARR dot length I plus plus. I can take as int sum equals to 0. So sum plus equal to ARR of I. So prefix sum of I equals to sum, right? Now we have the prefix sum built. Now we need to, what we need to do in, we need to now loop through each query. So I equal to 0, I is smaller than q dot length I plus plus. Now for each query, what we need to find is the starting index, and start is equal to q of I of 0 and end equal to q of I of 1, and we can print the prefix sum. So there will be one condition over here. Just a minute. If start double equals 0, then print prefix sum of end, right? Else print prefix sum of end minus prefix sum of start minus 1, right? This will be the our code. Now let's try to find the time complexity of this example, of this question. So for time complexity, what we are doing, we are finding the prefix sum, which we are doing in a one single loop, and it will take a time complexity of big O of n. Now the second thing what we're doing, we are querying through each loop in separately, querying looping through each query separately, so which will be equal to big O of q for looping queries, but these two are independent of each other. They are not, one inside other loops, but they are independent loops. So the total time complexity will be equal to big O of q plus n, right? Or few people also say big O of q, if where like if q is greater than n, then big O of q, or if n is greater than q, then big O of n. So basically, but big O of q plus n is also correct, right? So we'll not write it down. Okay, so this will total time complexity. Now take out space complexity. Space complexity will be big O of n, because we are using an extra space for storing the prefix sum. So only the downside is like we are taking an extra space here for the prefix sum. Okay, so the total time complexity comes to big O of q plus n, and space complexity is big O of n. So that's all for this video. Hope you guys have learned about the prefix sum, and we'll see you in the next video. Make sure you like the video and subscribe my channel. For now, bye bye. See you in the next video.